All right, class. Next video here is the actual activity for beam analysis. I'll kind of walk you guys through. Also, I will show you guys the SkyCiv beam calculator, which will save you a lot of time, make your life a lot easier. And so I'm excited for you guys to be able to kind of get some of the values here, but still hopefully understand a little bit more about the calculations and how to solve for them. Okay, so first off, go ahead and take a look at what we'll be doing. Okay, so the procedure here, we are assuming that we've got a few beams. All the beams are simply supported. What that means is on one side it's going to be a pin, the other side the roller, and they're all 16 feet long. We're dealing with a uniform load of 100 pounds per foot, so that's kind of dealing with the beam itself. And all concentrated loads are going to be 500 pounds. So that's going to keep things simple. All right, so you see here, we're going to find reactionary forces, as well as maximum moments. Okay. And then I have a link here to the SkyCiv beam calculator. So if you want to click on that, open that up in another tab here. I will go more into that shortly, but let's go back to our assignment first. All right, so first off, I do want you to show any work that you're doing as well as screenshots to get some credit for it. So there's a few things that I would be asking you to do. In addition, I want you guys to show you guys one more thing, especially for the end of course test, you will be asked to do some similar type questions. And so oftentimes you'll notice there are a few shortcut equations I want you to be aware of. And so for that, I am actually going to go back to our main page on Schoology. So if you are here on our Schoology page, come down to general resources, and then you're going to scroll down here to the engineering formula sheet. Okay, so when you're going to take that end of course test, you will have access to this formula sheet. And I want to start pointing this out to you guys so you know where to access some of the material. So as we scroll down here, some of this is not going to be super relevant for us until we get down here. First off, we see forces and moments, so that's kind of relevant for our current unit. And keep going down here. All right, at point or section 12, structural analysis. All right, so first off, if you notice, we've got some beam formulas. And if you see a question that looks similar to this, these formulas are going to be a lifesaver. Right? So for example, this beam formula, if you notice that it's a single point load right in the middle of a beam, then you can do some simple math, right? The reactionary forces RA and RB is simply going to be whatever that p value is divided by 2. And so if I come back over here to my actual activity, here it is. Okay, so then I can see reaction at A and B. This is exactly that situation, right? P is right in the middle being applied down. So if I look at my formula sheet, RA is equal to P divided by 2. Okay, so if my P value was 500, that means reaction at A would have to be, so R underscore A is equal to P divided by 2, which means P was 500, so it'd be 500 divided by 2, meaning 250 pounds. Right, and I can do the same for RB, since it's going to be the same for both, 250 pounds. And then I can also use this formula sheet to figure out the moment, right? So in this case, the moment was, it says P times L divided by 4. Right? So I can come over here to, oops, where's my activity? Moment, maximum moment is equal to P times L divided by 4. So that would be P was 500 times L, length of the beam was 16 divided by 4. And if I can do the math here real quick, I believe it will be 2,000 foot-pounds. All right, so that's one way of doing it, doing some simple calculations. That's what I would encourage you to do first. But I also want to see graphs on all of these. Okay, and so make your life a little bit easier, you can use what we did in class, doing some of the hand graphs, and I will show you that actually really quick. So let me briefly stop my sharing. Sorry here. Let me get that back for a second. Sorry. Okay, so let me stop share, and I'm actually going to show you on paper how I would have done this. Okay, so hopefully this is showing up. I know it's a little bit blurry, but what I would have done is I have my sum of forces here. So in this case, A and B are going up, and then the P is downwards, that's 500. So I'd have A plus B is equal to 500. And then I've got my moment, a sum of moments, right? So the first one would be 500 pounds times 8, right? So that would be positive. I made that one positive, even though that one's technically clockwise. And then the other one would be 16 times B, since it'd be 16 feet, and that's where force B is. And then I can solve for B. So B would end up being 500 times 8 divided by 16. And I can see right there, that would give me 250. And that's plug that back in to this equation. So it'd be 500 minus 250. And that's how I figure out 250 for each. And if I were to draw that as a graph, I got 250 going across. It drops off those 500 pounds where point P is, and then it goes to negative 250 on the other side. Okay. Similarly, remember I just figured out that the moment would be 2000. I could also find that by looking at the area of this graph. So that'd be 250 times 8. Since it's 250 and the point P was at 8 feet. So 250 times 8 is the area, which gives me the 2000. And that's how I can figure out my moment graph. All right. So most of you guys are probably thinking, hey, I thought you said you're going to give me a shortcut. So that's what I'll give you guys next. Okay, so coming back over to the computer, I am opening up SkyCiv. All right, so here is the beam analysis software. It's totally free and it does a great job. And this is how your life will be a lot easier. Okay, so let's start off. First off, I'm going to change the units. I want this to be in pounds. Units we've been using was feet, so it would be foot pounds. In addition, I've been changing this section units to imperial. All right, so how do we use this software? First off, we're going to come over here to add beam. The beam length, remember, was 16, so I'm going to type that in. Got a beam of 16 feet long. I'm going to add some supports. Okay, on one side, I have a pin support. Right, so I'm going to choose pin support, and I'm going to put that at 0 feet, so right on the left-hand side. I'm also going to add a support. Remember, these are all simple beams, so it's going to be a roller support at the other end. So I'm going to type in 16, and that'll put it right on this end. Okay. Next up, I've got a point load in this case. All right, so the point load, remember all the point loads, well, this one, sorry, I should say, is applied right in the middle, so it's 8 feet. And the load is 500 for all the point loads. So I hit add. Got that arrow coming down, so that's perfect. In the future, let me just show you guys how we would do this. If we were adding a distributed load as well, right, that would represent the weight of the beam. So it's all, for most of these ones, I think, maybe even all of them, they go from 0 to 16, covers the entire beam. And the magnitude on all of these are going to be 100 pounds. So the start and end will be 100 pounds the entire way. Okay, so if I were to add that, then I see that that's going all the way across. Okay. But for this first example, there is no distributed load, so I'm going to actually delete that one. Okay. If you want to mess around with it, you can also try adding some moments yourself or adding a hinge. But for the purposes of our assignment, this is all we need for the first one. And I can hit solve. Okay, so here's it solved out. I can see this is the exact graph that I had just drawn. Starts at 250, comes across, drops off those 500 pounds. So it's negative 250 until it gets to the end of the beam. And similarly, here's my moment diagram being shown. And the maximum bending moment was those 2,000 foot-pounds. Okay, so again, if you prefer to hand draw it, you can give that a shot. If not, I would take a screenshot or use the snipping tool, go ahead and grab that graph, and I would put that into my assignment, add that screenshot right here, as well as the screenshot for the bending moment. Okay, And if you were to pay for the full version, you can see it does all this beam deflection analysis, some stress analysis, stuff like that. So pretty cool, but for the purposes of our class, we'll just stick to the free version, and it gives us the information that we need. Okay, and again, kind of going back, you can see our shortcut equations work really well. We got the 250 pounds on both of those, the 2,000 foot-pounds for the maximum moment. And that's how we're going to solve these. Okay, so going forward, I just want to point out question 2. If you go back to your formula sheet, question 2 would match with this second example right here. So you can use these equations. Then let me take a look here at the other ones. 3 represents both of those, so that's not going to work. You're going to want to use SkyCiv on this one. We've got 2 equal concentrated loads symmetrically placed. You would want to use this equations right here. Okay, so that's what I should see on that one. And then 5 also combines both of those. So again, you'll probably want to use SkyCiv on that one. And then finally, a concentrated load asymmetrically placed, and that would represent this last one. So you can use these little shortcut equations to help you solve for that. Okay, and I believe that should be the full walkthrough on this one. For all of them, though, please do put them into SkyCiv. That's a good way to check your work, as well as having the shear and moment diagrams to be able to show them graphically. All right, so that's your walkthrough, guys. If you need help with anything, as always, please let me know, reach out, and that should get you going. Good luck.